Let's get started on today's notes over solving algebraic equations review. This is meant to be a review for Algebra 2. So we're going to look at some multi-step equations with variables on both sides. We're going to have special solutions as well. So when I solve each of these equations, the first thing I'm going to do is simplify the expressions on each side of the equal sign. So we looked at simplifying algebraic expressions in the previous video. Today we're going to do that to each side of the equal sign first. We're going to move the variable to one side and then we're going to solve it using inverse operations. So let's look at number 1. Now in Algebra 1, I teach this where I can draw a line down my equal sign and then I want x equals whatever the value of x should be. So x is on one side of this line and the value of the variable is on the other side. So I'll show you what that looks like here, but I don't use this line in Algebra 2. So 5 times x and 5 times negative 9. I get 5x minus 45 equals 25. So that line just helps me line up my equal sign. So now I'm just solving a basic two-step equation. I have to undo this subtraction. How do I do that? I add. What I do to one side, I have to do to the other. So 25 plus 45 is 70. And now I'm going to divide both sides by 5. Since that's 5 times x, I get rid of that 5 by dividing. What I do to one side, I have to do to the other, and I get x equals 70 divided by 5 is 14. Some of you might be using a calculator, or you might not be able to. So remember, we do this. 5 goes into 7, 1 time. 1 times 5 is 5. Remember this? 5 goes into 20, 4 times. 4 times 5 is 20. When I subtract, I get 0, and I know I'm done. Okay, so you might have to do a little division. Let's look at number 2. Number 2 is a little bit more involved, and they get progressively more difficult throughout this set of notes. So if I don't have any number in front of these parentheses, I can always put a 1. In this case, this will be a negative 1. That's what I'm going to distribute into every term on the inside of the parentheses. So I get 1y. Can I just write that? Sure. Can I write 1y? Sure, you can do that too. Plus 7 minus 6y equals 12. And now I'm going to combine like terms. Y minus 6y is negative 5y plus 7 equals 12. And now I'm back to my basic two-step equation where I'm going to subtract 7 from both sides. 12 minus 7 is 5. And now I need to undo that multiplication. So I'm going to divide. What am I going to get rid of? That negative 5. So y equals negative 1. So in number 2, I did not draw that line down my equal sign, but you can see my equal sign is pretty much lined up, right? Okay, it just makes it nice and neat. It's easier for your teacher to grade. It's easier for you to keep up with your work. It's just a good habit. So let's look at number 3. Number 3 is our first example where we have a variable on both sides of the equal sign. So let's do what that step 1 says and simplify both sides of the equal sign. So I'm going to distribute this negative 2. And I get negative 2a plus 2 plus 8 equals, and I'm going to distribute this positive 4. And I get 8 minus 12a. And now let's simplify. We still have, on the left side of my equal sign, I have some like terms that I need to simplify. So negative 2a, and now I'm going to combine these like terms. 2 plus 8 is 10. And I don't have anything on the right side of my equal sign to simplify. So it just stays like that. So now I get to step 2. This is the first example that has this. I need to move my variable to one side. So this entire term right here, I need to move to one side and it's going to affect that term over there. So how do I move it? I do the inverse of minus 12a. I add 12a. But what I do to one side, I have to do to the other. It gets rid of it on this side, and I've got negative 2a plus 12a is positive 10a plus 10. And now we're back to our basic two-step equation. So I'm going to subtract 10, and I'm left with 10a equals negative 2. And now I'm going to divide by 10. But wait, that's a fraction. Yes, and that's okay. You need to be very comfortable with ugly numbers in Algebra 2. So negative 2a is the same thing, or I'm sorry, negative 2/10 is the same thing as negative 1/5. So we're just going to simplify that fraction, and it's negative 1/5. Let's go on to number 4. And this is our first example that involves fractions, and that's okay. So I'm going to distribute this 1/2 into each term on the inside of the parentheses here. 1/2 x. Now, 1/2 times negative 5, I could write it as negative 2.5. But since I already have a fraction as a coefficient of x, I'm actually going to keep it as a fraction. So 1/2 times negative 5, remember you could do this, 1/2 times negative 5 over 1 and then just multiply across, you get negative 5 over 2 equals 3/4 times 4x and then 3/4 times negative 6. So I'm going to show you my little trick right here. 3/4 times 4x, I just do that. So that's going to be 3x. It's not as easy to do this. 3/4 times negative 6. So I'm going to show you. And the more you practice this, you'll get better at it. 3/4 times negative 6 over 1. So when I simplify this, remember I call it pre-simplifying, I can simplify this 4 and this 6. The common factor is 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So I go ahead and pre-simplify that. Okay, I make that a 2 and this a 3. And then I multiply. 3 times 3 is 9 over 2. And it's going to be negative. Did you follow that? That can be a little confusing for a lot of students. So off to the side, I would definitely say to write it out like this, then multiply across. 3 times 3 is 9. 2 times 1 is 2. Positive times a negative is a negative. Okay? If you need to, 3/4 times negative 6 over 1, you can always multiply across. 3 times negative 6 is negative 18 over 4 times 1 is 4. And then you can simplify that, and you still get negative 9 over 2. Whatever you want to do. So now let's, in this situation, I'm going to tell you that since I have a denominator that's the same, and I actually have a little like 3-minute tutorial video over how you can get rid of your denominator, but all of our denominators are the same in every single fraction that we're looking at. It's a 2. Well, if I multiply everything over here on the left side of my equal sign by 2, every term, like if I distribute a 2 into every term, I'll get rid of that denominator. Well, what I do to one side, I have to do to the other. So what I'm going to do is multiply this entire equation, every term in it, by 2. And watch what happens. 1/2 x times 2 is just x. Negative 5 over 2 times 2 is just negative 5. 3x times 2 is 6x. Negative 9 over 2 times 2 is just negative 9. And boom, we got rid of our denominators. It's wonderful. I would much rather deal with an equation that looks like this. So now let's move our variables to one side. Minus 6x, and I get negative 5x minus 5 equals negative 9. What do I do at this point? Add 5 to both sides. Negative 5x equals negative 4. Now I'm going to divide both sides by negative 5, and x equals positive 4/5. There you go. Let's look at our last two examples. Moving on to number 5. Number 5, I'm going to simplify each side of the equal sign. So I'm going to distribute this negative 4, and I'm going to distribute this 6 over here. So I get negative 12x minus 8 plus 7. And now I'm going to go ahead and distribute the 6 over here. 6 times negative 2x is negative 12x. 6 times negative 5 is negative 30. And I still have terms on the left side of my equal sign that I need to combine. So negative 12x minus 1 equals negative 12x minus 30. And now let's move our variable to one side. So I'm going to add 12x. What term does it affect? The other x term. And what do you notice here? The x's, the variable, cancels out. So I'm left with this right here. -1 equals -30. When you get rid of your variables and you end up with a statement that is not true, this is not a true statement. -1 does not equal -30. When you get rid of your variables and you end up with a false statement or not a true statement, your answer is no solution. You could write that, or you could write this symbol right here, empty set. That means no solution. There's no value of x that I could plug in this equation that would give me the same thing. What is on the left is equal to what is on the right side of my equal sign. There's no value of x that would make that equation true. So now let's move on to number 6. Don't let these fractions scare you. Okay, so 2/5 times each term on the inside of these parentheses. So remember, 2/5 times, look at that, boom, 2y. Now let's look at the next one. I'm going to show you how I do this. 2/5 times -10, well, obviously it's going to be negative. Instead of just canceling that out, that becomes a 1, that becomes a 2. So really, I've gotten rid of that denominator. It's just 2 times -2, which is -4. Equals -1/2 times -4y, positive 2y, half of 4 is 2. -1/2 times 12 is -6, and don't forget I have that 2 over there. So on the right side of my equal sign, I still have some terms that I need to combine. So let's go ahead and do that. We're going to rewrite it, simplifying it one step at a time. Some of you might already see what's going on here. 2y minus 4 equals 2y minus 4. Yeah, that's a true statement. I'm actually going to show you to the very end. Watch what happens when I move my variable to one side. When you get rid of your variable and you end up with a statement that is true, this is a true statement. -4 does equal -4. When you end up with a true statement, your answer is, boom, that little sideways 8, your infinity symbol. Infinitely many solutions. That's what that means. Infinitely many solutions. You could plug in any value of x. It doesn't matter. I'm sorry. Any value for y, plug it in, and your equation would be true. What's on the left would equal what's on the right. So some of you might already have recognized that right here. 2y minus 4 does, in fact, equal 2y minus 4. So that concludes your notes over solving algebraic equations review. I hope it was helpful. Good luck.